present you how we improve throughout history our math scanning capabilities, and it's also closely correlates to my history in the company as well. And so I'm here in Photomath for 7 years, even before, since I graduated in local university, and doing a lot of things, mostly ML, but also a lot of other things as well. And in Photomath we have around 300 people right now working on the app. There are 3 offices, actually, 2 in Zagreb and one in San Mateo. And actually what we do is we create an app, Photomath, that actually helps hundreds of millions users worldwide, students with maths. And this is a short video of how do we do it. Okay, so the core feature of the app is actually scanning a math problem and providing a solution for it. And we do it in 2 ways. We have automatic scanning, and so automatic solution distribution to the users, and manual. Automatic part is done in like 85% of the time. So the user scans an image, it goes through our recognition engine, which returns a structured form of a math expression, and afterwards it's passed through a solver, which returns all solutions we have for that specific math problem. In 5% of the cases right now, but it's increasing, we are scanning a math problem, mostly word problem. We are doing some feature extraction with some ML, and we have a task matching system that matches that image against our solution database, where around 10,000 people throughout the world are actually contributing to us by writing the solutions for detailed solutions for every single math problem they encounter. And actually, after that, we also give back to the users, and users are hopefully happy with it. If we step back to the late 2014, so Photomath's first version worked in a way that we had a recognizer as a two-step model. So first was a classic ML OCR in-house built OCR that actually from the image returned all the characters, and then there was a parser that collected those characters into a tree of expression tree that represents a math formula. After that, it's passed through a step-by-step solver, and we get a solution. In 2016, we wanted to support handwritten math problems. And also at the same time, deep learning was starting to be, let's say, production ready for that kind of things. And we employed actually deep learning to replace our classic ML-based OCR. How we did it? Actually, we looked at that problem as an object detection problem, and instead of detecting like dogs, cats, and so on, we detected numbers, like fractions, signs, and whatever. And actually, we accomplished what was really then a great accomplishment that we surpassed our actually so classic ML approach, non-deep learning approach with deep learning approach, and not only that, but we still think that in 2016 we were the first ever deep learning based OCR that was actually running on device, so not in cloud, but on device in real time. And it was great, and we used it till 2020, but it had some problems. So the whole setup had a problem that the OCR was doing great, but the step afterwards, the parser, that was trying to parse that expression was just like fix after fix after fix, and we ended up in the place of diminishing returns. And we knew that with that kind of approach to that problem, we couldn't do many things. Like we couldn't read, for example, geometry. What we can do now. So in 2017, we tried a moonshot project called end-to-end recognizer system, and what we did is we tried to replace the OCR, that was deep learning approach, and parser, which was just this C++ module, with one single end-to-end trained neural network. And how we did it? Actually, it was a combination of approaches from computer vision and NLP. So we had a convolutional backbone, and on top of that, bidirectional LSTMs, which were, let's say, state-of-the-art at that time, and it worked well. But the thing is that it didn't work well for problems we didn't have a lot of examples. And the main problem was that we lacked data, and even more, we lacked data infrastructure needed to solve that problem. And by the mid-2020, so we focused more on solving part. So recognition part was doing great, and we were satisfied with it. Okay, we weren't able to solve, let's say, geometry and so on, but we had a lot of things to do in terms of solving things we are supporting now to be recognized. At the same time, we worked a lot on our internal data infrastructure, and at the same time, so by mid-2020, we finally felt, okay, we need to make a step forward and do something with our current approach. Also, what we read then was a lot of articles about transformers and GPT-3 actually changing the whole area, and we thought of, okay, if it can work on things like generating, there was guitar tab generation, or generating some SQLs from some text, well, maybe it can do our problem well as well. So what we did, we started with some scribbling, and ended up with an idea that we use a classic transformer approach. So we have a transformer that, let's say, translates from English to French, and we can maybe replace English with image and French with match problem in most simple way. And it turned out that it really, in a few months, we ended up being on par with our current system. And we saw that by adding more data, but by experimenting a lot with the model and architecture, we saw that it will surpass a lot our current system. So we concluded, okay, this is no longer a moonshot. We need to push it into production as soon as possible. And every year in September, kids are back to school, and we have our largest release, and we wanted that to be enabled in our new release. It was a tight deadline. We wanted we had 6 months to train a model good enough to surpass our current system, also to surpass it on all specific cases that our current system was doing well, to be able to ship it to production. And we employed 12 engineers in 5 different areas of the whole ML landscape. And actually, we could do it with less engineers, but what we actually wanted was to grow the engineers as well on this tight deadline. It's a really interesting project for them to be able to, after that, take on their own features and do it on their own. And at the same time, it was a company-wide effort, because we were moving all things Photomath does on cloud, because we were till then we were on device, which means that every neural network, every solving capability was done on device, and it started to become a problem, not for recognition but for solving, because we ended up creating so many so large content database, so many solving capabilities that we couldn't put it anymore on the device, and it provided us an opportunity to move the recognition as well on cloud. And actually, what we did is, and what we have now is a torch serve based deployment, which I truly don't recommend to use, and it is on top of our multi-cluster setup on, like, we have in Europe and US 2 clusters, and we have like six several rooms, and we have the GPU-able nodes that are actually running our inference. So this is how it looked back then when we deployed it in September, and it looks pretty similar today. And this pink thing here is our recognition engine. So everything is on cloud. And while I'm talking to this, so 1 million solutions are being scanned in around 20 minutes, and this talk is around 20 minutes. So this is one interesting thing, because it just shows you how important our infrastructure is. So every 20 minutes, around 1 million solutions are presented to our users, and not to talk about all the events we collect, like all the taps from the on buttons from the app and so on. So in September, what we achieved actually was increase from 64% of the accuracy of our old system to 90%. And 64% was actually state-of-the-art in that area. So we really increased it a lot. And when we released it, we tracked a lot of business metrics, because we don't care, we care about our accuracy of our model, but what we care the most is how users are, does it help the users in how much? And it seems that, like, every business metric that should went up, every business metric that went down, went down, and like, we have a lot of premium content, and actually by 55% we increased by this improvement. So nothing else changed. We increased the number of clicks to our premium content. And there is also some surprising results. So first thing is, although we weren't focused in supporting things like really blurry images, and it can be even worse than this, it's really, we saw that model is able to read blurry images even better than our annotators that we have at sometimes. And more interesting thing is that, and this is like the most interesting image for me. So this is my favorite image. So you have what model can see is this red triangle, and it can read this whole image. Although this theta is not appearing on the image that the model sees. This sign is not appearing. This square is not even on the image, but it really is there. And actually, what model learned is the statistics of math problems. And actually, this one math problem appears 1/1,000,000th of a time in the whole dataset. So it isn't so common, but model really is able to infer, like, if there is a square here, and it probably should be square here, because why else should here be a bracket, and so on. So today we have an AI department that is focused on many research streams, and we have two supporting teams. One is data infrastructure team, and another is MLOps. So MLOps team works on our CI/CD pipelines, maintains and takes care of our services in production. We have tens of auto-scalable GPUs constantly running, and also they maintain our on-prem cluster of GPU servers. We have around now around 1 terabyte of GPU memory available to use. We have also data infrastructure team that does everything from data collection sending it to annotation, returning back to, and creating actually data sets for machine learning models. They also do the whole new buzzword data mesh and all those things, and they're really great. And we also have annotation team, which is a team we couldn't do without, so we really want high quality annotations, and this is why we have an internal annotation team. I think there is around 90 of them at the moment, maybe 100, and it was really impossible without them, because all those like commercially available annotation platforms are great, but if you want really good annotations, we saw that for some problems you need to have your own people who are annotating, and you can work with and communicate and see actually visualize what is the problem you're working on. About the future, so in terms of that math recognition, there are like three main dimensions in which we can improve. One is accuracy, one is latency, and one is domain. So accuracy is something that we didn't want to improve anymore because it is good enough for now. And it seems that even though we aren't improving it directly, it's still increasing. Every time we do something, we add a new data set, we support some new feature, it is increasing, so it's great. Latency is good enough for now, we are also not touching it. What we are doing actually the most is supporting new problem types. And we are now able to support simple geometry, which is not yet in the app, but we are planning to release it. And we are supporting some really simple combinations of words and mathematical expressions. But we also want to be able to support graphs, to support some like maybe word problems, and of course things like chemistry or even things like Sudoku, because why not? And so delta between September this year and today is that we decreased the error rate from 10% to 8%, although we weren't focused on that. We also added a lot of new features, and we saw that now 80% of all the issues we have isn't because of recognition, but because of solving. And we are actually now focused on implementing more and more solving capabilities in our system. And this is one example of something that we are able to read, and it's no problem reading, but what to do what to return to the user for them to be, so it is a problem that we sometimes don't know what the users actually want. And if they scan this, we actually don't know what to return to them, for them to be satisfied with the app. So there is a lot of problems that are just like that, and we're trying really creative ways to see what actually users want. Another thing we are working on is finding actually identical copies of the same problems, and trying to, if we have that 5% I talked about, like manual solving of problems, so we are trying to identify the problem that already is in our database and returning to the user. And it is actually a pilot is released this week to one like small percentage of the users. We also have that marketplace where math experts can actually earn money by creating solutions of problems we aren't able to solve automatically. And we do, this is currently on pause, but we are doing a lot of things in terms of optimizing their time and efforts to solve that problems. And this is one type of like clustering of some similar graphics and stuff like that. We also do a moonshot research, so many moonshot research, but most interesting thing is probably like understanding word problems. So the idea is from textual representation of a problem to actually synthesize the solution of that problem. But it is really something that we are just trying every once in a while to see what is now, how well are we able to do it at the moment, because nowadays it isn't able, it isn't feasible, especially not to be real time. And this is what we aim. This last video of this a bit retrofuturistic thing we did, how Photomath could work, could look in the future with some like AR capabilities.
Photomath, what is this?
This is a quadratic equation.
What is a quadratic equation?
A quadratic equation is an equation with the variable x squared.
How do I solve this problem?
It can be solved by applying the quadratic formula.
Is this correct?
Congratulations, your solution is correct. Would you like to graph this equation, practice similar SAT problems, or connect to a live tutor?
Graph, please.
The solution is -3 1/2 are where the quadratic function crosses the x-axis.
So we done a lot of features. There are a lot of features missing for this to happen, and this is why we always look for new great engineers to help us with it. And the last thing I want to show you a few interesting things, like I don't know if you knew, but in Snapchat you can scan a math problem and actually Photomath will turn up. And I don't use Snapchat, so I don't know if it's enabled in Croatia, but it is a 2 years old version of Photomath that is working there, so maybe you can try it. Yeah. Another thing interesting is things that people are scanning that isn't maths. So people are scanning chemistry, for example, some chemical equations or whatever, some like structures, and physics as well. Some they are scanning a lot of those things. So I don't know how it's called, but yeah, and I don't know what they want us to do with this. Yeah, and the most interesting thing is like electric circuits are really so people are desperate. They are scanning a lot of electrical circuits. So we probably will at some point do something with it, because it's like so many of them are scanning it, and also music. And the most interesting thing for me is this thing. So they're scanning a lot of like we thought of maybe just returning them ad for like our job ad or something like that, because I don't know what to do with it. And there's a lot of like weird things, like for example this thing here, and we don't know what people are doing, because people don't know maths and they are scanning things and they want help. And we are actually doing a lot of work in trying to extract what actually people were trying to be helped with from things that doesn't make sense. And for example, here you can see what people are actually want, but this isn't valid. And about most scan problems, does anyone know what most scan problem is with Photomath? Okay, so it's not 2 + 2, it's actually this integral. And this is like free Wi-Fi integral. And one interesting thing with it is that here dx is under like this radical sign, so it isn't valid actually. But yeah, and we're also doing efforts to like fix it. So this most commonly scanned, then 2 + 2 equals, and then 2 + 2. Without equal, and then like 1 + 1, 1 + 1, and then this viral math problem is also like common. And okay, this is like, and this is interesting because we have there's one game that has this as a step of the game, and you need to solve this, so people are scanning it with Photomath. And okay, most common scan variables. algebra is like 60% of everything, and calculus is like 10% and so on. And that's about it. So if you have some questions, you can ask me now, or I'm not sure whether I do have enough time.
Yeah, you do have time for questions, don't worry. I'm coming to be your help. Do you have any questions? I'm so sad that this app didn't exist while I went to high school, because maybe I would have finished something other than film production, but you know, who knows. Okay, we have one question here. And this is for you. Thank you.
Hello, thank you for a great presentation. Just one question, for finding this step-by-step solution for complex equations, let's say, you showed us a few ones, is it always the exact pre-prepared solution for this problem available, or can we use machine learning to solve a differential equation or something?
So the idea is actually we don't use like static content. We use for some things, but mostly, and we also don't use machine learning for that. Actually, what we do is we use expert system based on tree manipulations, and the idea is that we have the whole team of mathematicians who are actually professors of maths, and they tell the engineers what is the, and not what, we aren't focused on solving and giving the right answer to the user. We are focused on giving the right steps and the most helpful steps in most humane way of solving. And this, what we are actually doing is that we have some search system, like some expert system that runs like all things that we can do with that problem that are like helpful for the user, that are easily explainable, and we return that to the user. So no machine learning is done in that way, in that part, and I think that it is a thing that we don't want machine learning at the moment, because we are focused on accuracy. So we want to be as accurate as possible when we return a solution for the user, and machine learning is great when you can have a noise, and for example with images, with scanning, it is okay to fail sometimes, but when you provide the solutions, you really want to be sure that this is the right solution, and this is the right and helpful steps for the user.
Okay, thank you.
Do we maybe have another? Yeah, we do. Here in the first row, in the second row. Is it the second one? Yeah.
Hi, first of all, thanks for the great presentation. My question is about what's the difference between you and like Wolfram Alpha and Wolfram Mathematica, and also related to this question, if for example some differential equation has no expert solution, what will you return to the user?
So if something doesn't, so one of the solutions is also that it doesn't have a solution. So it is valid. If it isn't analytically explainable, we'll probably then try to just solve it through like a classic calculator. And regarding Wolfram Alpha, so Wolfram Alpha actually focuses on the solution. And they have steps, but their steps they are really, if you have tried it, their steps are they aren't humane, and we are really trying this to make it understandable to the user and not just generate some steps. And I'm not sure whether Wolfram Alpha has now like free steps for things. We have so app is like 99% free. There are some like cases where if you scan something that a user has written the whole solution for it on our marketplace, it will you will end up with a paywall. But if it's automatically generated, we are just able to provide you free with it.
Okay, thanks.
Maybe some other question? No? We're done with Ivan. Thank you very much.